Hey everyone, and welcome to The Explainer. Today we're doing something a little bit different. We are literally constructing an architectural blueprint from the ground up for a highly reliable, locally controlled smart home and office setup. Look, if you've ever dealt with smart lights that just won't turn on because your internet is down, or automations that lag just long enough to be incredibly annoying, you are absolutely in the right place. We are going to design a system with unlimited power, focusing entirely on a bulletproof infrastructure that actually works seamlessly once you build it. Let's get into it.
Okay, let's dive into this. Here is the blueprint we are building today, going from the foundation straight up to the final room. We're going to cover the cloud problem, establishing the local brain, picking wired protocols, building out a mesh backbone, and finally, the automated office. All right, kicking things off with section 1, the cloud problem. Before we can build something truly bulletproof, we really have to look closely at the fundamental flaws of your standard, out-of-the-box smart home setups. Now, I want to ask you this direct question. Why do smart homes fail? You know exactly what I'm talking about. It's a super frustrating reality for a lot of people. Well, the answer almost always comes down to external reliance. Take the smart home company Insteon, for example. They recently went bankrupt literally overnight and just switched off their cloud servers. That meant anyone relying on their cloud-based ecosystem suddenly couldn't turn their own living room lights on or off. Madness, right? Or look at Chamberlain's MyQ garage door openers. They've been actively breaking integrations and blacklisting connections in this weird cat and mouse game with their own users. Basically, systems that rely entirely on the internet are fundamentally fragile. Think about it like human biology. A cloud-based Wi-Fi smart home, that's like your body relying on a satellite in outer space just to tell your heart to beat. If that signal drops, everything just stops. It's laggy, it's a massive privacy risk, and it totally fails without the internet. But compare that to our goal today, local mesh networks. This setup acts like a healthy nervous system right inside your own house. It's completely locally controlled, totally private, responds instantly, and best of all, it's entirely self-healing. Moving right along to section 2, the local brain. Let's pour the foundation of our local architecture. Every robust nervous system needs a solid brain. To achieve maximum reliability, you absolutely need a dedicated, standalone machine running Home Assistant. Now, a lot of enthusiasts start out by running Home Assistant kind of piecemeal in a virtual machine on a server that's busy doing a dozen other things. But when you want to build this right, starting with a clean slate and repurposing a dedicated mini PC, something like an HP EliteDesk G3 with a solid-state drive and plenty of memory, is far superior. It completely isolates your smart home environment, meaning if your media server crashes, your lights don't go out with it. You just mount this central brain in a closet right in the middle of your home to make sure the signals can reach everywhere. That brings us to section 3, wired protocols. We've got our brain, but now we need to transition to how this brain actually communicates, acting as the brainstem of our entire operation. So here is the golden rule. We want to have as few devices as humanly possible relying on our Wi-Fi. Wi-Fi gets super congested and it's incredibly power hungry. Instead, we are going to use Z-Wave and Zigbee. These are local, low-power, wireless communication protocols designed specifically for smart devices. By using these, we completely avoid dumping dozens of light switches and sensors onto our Wi-Fi router, which keeps our local network incredibly fast and very secure. Now, what's really interesting about this slide is how we actually make that connection. To physically connect these protocols to our server, we plug specific wired adapters from Nabu Casa, they're the open home foundation folks behind Home Assistant, directly into our standalone machine. The Z-Wave 2 gives us our Z-Wave network, which has exceptional range and security, so it's absolutely perfect for things permanently embedded in your walls, like your light switches. Meanwhile, the ZB2 gives us our Zigbee network. Zigbee has this massive ecosystem of devices, making it perfect for small battery-powered stuff like temperature, humidity, and motion sensors. Next up, section 4, mesh backbone. Let's see how this all builds out into the infrastructure itself, basically running the electricals of our architectural outline. Listen, this right here is the absolute secret to a bulletproof smart home. Hardwired devices, specifically smart switches that are wired into your home's neutral wires, do way more than just turn on your lights. They act as active network routers. This means they actually take the Zigbee or Z-Wave signal coming from your central brain and they repeat it, actively bouncing it down the hallway and across the entire house. They're creating this incredibly robust, self-healing mesh network that reaches every single hidden corner of the property.
To build out this backbone, there are a few highly tested hardware choices you'll want to look at. First up, the Aqara H1. It has a super premium feel and built-in energy monitoring, but its true superpower is called decoupled mode. You can physically cut power to a normal light or literally decouple the buttons so it just sends an automation signal straight to your smart bulbs without cutting their power. So cool. Then there's the Candido rotary dimmer. It features an intuitive physical knob that anyone, even your guests, knows how to use. But amazingly, it acts as a network router even if your older home doesn't happen to have a neutral wire in the wall. Finally, the Zeus switches. These offer excellent Z-Wave range and scene control. You can double tap a switch to trigger completely different automations, like setting a 20-minute sleep timer for a child's bedroom.
I've had absolutely no issues. They've been rock solid. I just love this quote. It's straight from our source material regarding these local setups, and it perfectly emphasizes the ultimate goal here: absolute reliability. When you build a local infrastructure using dedicated servers and hardwired mesh repeaters, it stops being this finicky weekend tech project and just becomes a seamless, invisible part of your house.
Which leads us perfectly into Section 5, the automated office. Let's transition to the climax of this explainer, taking all of this rock-solid base architecture and showing how it expertly powers a small home office. This brilliantly illustrates the true power of local control. Look at this automated video call routine. Because the whole system is local, it responds instantly. Literally the millisecond your computer webcam activates for a meeting, a cascade begins. Step 2. Your smart lock instantly secures the office door so the kids can't accidentally run in. Step 3. A hallway light changes to red, serving as a visual warning to the family that you're busy. Step 4. Your phone automatically enters Do Not Disturb mode to keep you totally distraction-free. And the best part? The moment your camera turns off, everything instantly reverts right back to normal. It's like magic. But it's not just about meetings. The infrastructure we built supports these highly specific environmental automations without any lag at all. Say you're working hard with the door closed. A sensor continuously monitors the CO2 levels. If that air quality drops, LED strips in the corner subtly flash red. A simple dashboard button press then opens your window shades and activates the fans to clear the air. Got a plant? A soil moisture sensor stuck right into the dirt monitors it, turning on a specific light when the plant needs watering, literally saving it from certain death. And honestly, just sitting down and waking up your PC automatically kicks on a desk fan to keep you cool. Let's look at this number, 83. We can use this number to represent the massive potential percentage boost in your overall productivity when you actually have an environment that breathes with you. Think about it. When you aren't sitting in a stuffy room getting drowsy from rising CO2 levels, and when automated fans drop that CO2 quickly, your focus and your output are absolutely going to skyrocket. Of course, to be productive, you really need the lights to stay on. The absolute biggest mistake in office automation is having your lights turn off while you're quietly typing at your desk. We've all been there, waving our arms in the dark, right? Standard PIR or passive infrared sensors are great at detecting big movements fast, making them perfect for turning lights on when you walk in. But they totally fail if you sit still. The real game changer is millimeter wave or wave sensors. These incredible devices detect micro-movements, literally stuff like the rising and falling of your chest as you breathe, ensuring the lights literally never turn off while you are in the room. So the crucial point is this pro tip right here. For totally frictionless office lighting, combine them. Use a basic dumb PIR sensor pointing right at the door to instantly turn the lights on the millisecond you walk in. Then, use an ultrasound or wave sensor monitoring your desk area to prevent those lights from turning off until you actually leave the room. The perfect combo. And as we wrap up our blueprint today, please never forget this golden rule. Keep physical switch backups. Notice how throughout this whole thing, we didn't just put in smart bulbs, we installed smart wall switches. Your smart home should be completely intuitive for guests and your family. If your automation logic ever fails, or hey, you just want to take a nap and manually turn everything off, a physical wall switch ensures the system remains totally controllable. It's the ultimate fallback. We've designed a self-healing, locally controlled, lightning-fast infrastructure. You literally have the blueprint in your hands. So I'm going to leave you with this question. What manual task in your office are you going to eliminate first? Is it going to be the lights, the climate, or the interruptions? Start planning your local server infrastructure today and take back your time. Thanks for joining me on this explainer, and I'll catch you on the next one.